spectroscopic properties of transition metals or coordinated compounds. The electronic transition, what you understand up till now, is the old stuff of electronic transition from bi to bi star, from N to bi star, or from sigma to sigma star. This is what's applying for organic and inorganic material. And it has a certain range of ultraviolet radiation where these absorptions, sigma, sigma star, bi star, N bi star, are lying, existing في UV spectrum. The spectra of coordination compounds or complexes or transition metals, as I told you before many times, it's a DD electronic transition. It's from the T to G to EG in octahedral complex, from E to T2 in tetrahedral complex, where a separation, that is splitting, that takes place in the d orbital is never so large difference in energy like bi star or N bi star and so on. So it's very little energy barrier. So this very little energy barrier takes place in the visible region of spectrum. That's why you should learn from now that the spectroscopy of material is always named UV visible. All machines or spectrophotometers which are measuring electronic transition are called بتسمى UV visible spectrophotometer. السبكترا اسمها UV visible spectra. It's combined between the UV range of energy and the visible range of energy. Again, I repeat now so that it's clear by you that the sigma star, bi star, N bi star are lying in UV region. T to G, EG, or T to E, or E to T2, and so on, are lying on visible region. الناس اللي مش مركزة أو مش مجمعة كان المفروض تجاوبوا معايا في السؤال ده إجابة واضحة وصريحة إنك استوعبت أو فهمت اللي أنا بقصده. طيب بالنسبة بقى للإلكترونيك سبكترا، ولما أقول إلكترونيك سبكترا it means ABC, electron transfer, electron excitation. An electron goes from a ground state to excited state. So it's very important for you to understand what is the ground state. You know now that electronic transition, an electron will jump from a ground state to an excited state. الناس اللي مش لاقيين مكان ورا، الاماكن هنا كتير فاضيه. تعالوا هنا في البنش الثاني والثالث في اماكن فاضيه كتير. So the electronic transition from a ground state to an excited state, we have to define, we have to know what is the ground state. Many times, and now especially, I told you that the electron in octahedral complex transfers from the T to G to EG. Is this a ground state and excited state? Or this is just an atomic orbital?
Atomic orbital.
Or a molecular orbital, since we take the molecular orbital last lecture بتاع الليجن فيلد ثيوري وقلنا هيبقى فيه bonding تحت هنا دول البوندنج اوربيتالز واللي فوق دول انتي بوندنج
نون بوندنج.
فالالكترون لو هيطلع من هنا لهنا ده قضيه معينه. But if it transfers from here to here, it's completely different story. So we want to know, we want to define the word what is a ground state. يعني ايه ground state? So the scientists sit together and think together, brainstorming, to know what is the ground state, and they came out to find what's called a term symbol. Symbol for a term which represent what is the ground state. So at the same time, we need to know the term symbol of the excited state. So when I say that an electron goes from the ground state, which is E2B5S7, whatever the name that we will learn now how to find it or how to get it. So I know what is the ground state and what is the excited state. After that, we will apply some rules and نبتدي. Believe me, I can say a lot of words which might hurt you, but I don't like it. I like you all as my children. So please don't enforce me to be bad with you. Again, what we are going to learn this lecture is what's called term symbol. The term symbol is a symbol, a new symbol which you didn't get before, which represents what is a ground state and what is an excited state. Back to the last lecture to get the point. We have 6 sigma ligand bonds. 12 electrons are coming here. So 12 sigma electrons ligand character. Electrons اللي هنا, the electrons in this bonding area in the molecular orbital diagram have the ligand character. It's ligand electrons. Electrons